Okay, hi year 10, 11. You guys are going to start looking at Pythagorean identities. And there's a fair few proofs involved in here. So where these rules generally come from are the unit circle that we're all used to looking at with our stations to central. And it's all based on the formula for the unit circle, which is x squared plus y squared equals r squared. That's your general formula for a circle, which you should have seen last year. And it's also based on our right angle triangle that sits within that circle for, say, any point P in our quadrant. We have a 1, so we'd actually change our circle to x squared plus y squared is 1 squared, or 1, and it's Pythagoras' theorem as well. So the x-coordinate squared plus the y-coordinate squared is equal to the radius squared, which is 1. So all our formulas here are based around that, and we can rewrite that one as sine squared plus cos squared equals 1, but we'll have a look at that down further a little bit. Okay, going down, you guys know the quotient identities. So we've already looked at tan theta equaling sine theta on cos theta. So you're familiar with that one. We know cot theta is 1 on tan theta. So that flips our sine identities upside down so that it becomes cos theta on sine theta. We know our reciprocal identities. So you're familiar with these. So if I jump back to the formula sheet that you guys will get for your HSC, your trig functions are on there, remembering your trig identities are on there. So you've got those in there. But the rule that we're going to have a look at today, the cos squared plus sine squared x is 1, is on that formula sheet as well. So you don't need to memorize those. You've got access to those. And that's our first formula here. So our sine squared theta plus cos squared theta is equal to 1. You don't need to memorize it, but we will be using that a fair bit. The bottom two down here, you can work that one, each of those out by dividing through by either sine squared theta or cos squared theta from this identity. So let's have a look at that. So if I write down my rules, sine squared theta, sorry, I'm not really well today, plus cos squared theta equals 1. If I am to divide each of those terms by cos squared theta, let's see what happens. Cos squared theta on each of them. Because I'm doing it to each term and on both sides of the equation, it's still balanced, so that's allowed. So what we're going to have now is on the first term there, sine squared theta on cos squared theta is tan squared theta. Because we know sine on cos is tan, so sine squared on cos squared is tan squared. Cos squared on cos squared theta, we cancel those guys out, and we end up with 1. 1 on cos squared theta is going to be sec squared theta, because we know from our identities that 1 on cos is sec. And that gives us our second rule there, guys. Let's have a look at the third one. So if I write down my basic rule again, that it's sine squared theta plus cos squared theta equals 1, what I now need to do is divide each of those terms, this time by sine squared theta. And this time we'll get our third rule. Oops. Okie dokie. So looking at what's happening there, sine squared theta on sine squared theta is going to be equal to 1. Cos squared theta on sine squared theta, well, that's the opposite of cot. Remember, the opposite of tan. Sine on cos is tan, so cos on sine is cot. And we've got squareds, so it's cot squared theta. And our last part there, 1 on sine squared theta is cosec squared theta. Because we know 1 on sine is cosec, when we square it, we just end up with the squared term. So these two terms here are our two over here that we just need to divide through to be able to work out. Okay, let's go and use all of those things that we've just gone through and see if we can simplify some trig equations. So, example number 1, it says simplify cos theta on tan theta. Okay, well, let's see what we know. We can't really do much with cos theta, so I'm going to leave cos theta as cos theta. But we know from our rules that tan theta is sine theta on cos theta. So what I'm doing is just replacing my tan theta with the sine theta on cos theta. And now, just like we did in our algebra topic, we can cross out terms that are similar on the top and the bottom. I've got a cos theta and I can cancel that with a cos theta, so I end up with sine theta as the simplified version. Okay, let's have a look at number 2. Simplify the square root of cos to the power of 4 theta plus sine squared theta cos squared theta. Okay, with this one, I think the square root sign is the thing that's going to trick a lot of people. But at this point, let's just leave it there. There's nothing we can do with that. And let's look at what we can do underneath it. Now, I can see that there's a cos out the front in this term and there's a cos in the back term. So cos is the common term. The biggest cos that I can pull out is a cos squared theta, because I have to the power of 4 in the front and to the power of 2 at the back. So if I pull out and factorize by cos squared theta, I'm going to be left with cos squared theta as my first term, because remembering when we add our indices, the 2 plus 2 gives me 4, so I've got cos squared theta left in there, plus sine squared theta. Okay, now you should be able to see something in there. We know sine squared theta plus cos squared theta equals 1. So we can replace that by the number 1. So let's pop that in there. Got the square root of cos squared theta times 1. So I don't even need to put that times 1 in there now. I can just leave it as cos squared theta if I like. We've got a square root and a square. They cancel each other out because they're opposites, and we're left with cos theta as our answer. Moving underneath, what question 3 asks us to do is to show something. Show that. And on part A, we're showing that tan theta plus cot theta equals sec theta cosec theta. Now, we've had a little look or a little introduction to showing that rules, and this is where I want you to start on the left-hand side. So remember, we called the left-hand side LHS, and then we're going to be referring to the left-hand side of our equals sign as the left-hand side. Our right-hand side of the equal sign is our right-hand side. So we don't need to do it all in one go. We need to move from our left-hand side and try and turn it into the trig functions that look on our right-hand side, that are there. So let's start off with left-hand side, and let's write down our left-hand side. But don't worry about the right-hand side yet. Have a look at it to sort of see where we want to maybe head, but at this point we're not really sure. So we've got tan theta plus cot theta. Now, I know straight up that tan's sine over cos, and I know cot is cos over sine. So let's pop that in and see if that helps us out. And sometimes it can be a little bit of trial and error, playing around with them. Okay, oops. Just fix that bottom line up there. Okay, so I've written my tan theta as sine theta over cos theta. I've written my cot theta as cos theta over sine theta. Let's see what we can do now. I'm thinking we're just going to simplify it as an algebraic fraction. We'll times our bottoms together to get cos theta sine theta. We'll cross multiply to get our top terms. Sine theta times sine theta is sine squared theta. Cos theta times cos theta is cos squared theta. And now I'm looking pretty happy with that, because my top line, sine squared theta plus cos squared theta, is equal to 1, and my bottom line stays as it is. But what we can do with our bottom line is we're going to think of it as two terms. 1 on cos theta times in by 1 on sine theta. It's exactly the same as what we've got the two terms together, but in splitting it up, it's a little bit easier to see that 1 on cos theta, think what that is. That's our sec theta. I think we're there. 1 on sine theta is cosec theta. So we are there. So we've proved the right-hand side. So I've got there to the right-hand side, and I'm just going to be equaling that to the right-hand side. And that's all that is. So don't panic about the right-hand side at the start. You start at the left, we manipulate it, and turn it into what we hope is the right-hand side. Okay, let's move over to B. Remember, we're still showing the left-hand side is equal to the right-hand side. Our left-hand side says 1 plus cos, should be a theta in there, over sine squared theta equals 1 over 1 minus cos theta. So I'm going to start like before with my left-hand side. We write that one down, and we see what can we do. Is there anything we can do with any of those terms? I'm looking at it, and straight up I'm thinking, okay, I know there's a rule with a sine squared theta in it, and that's going to have a cos squared theta in it. So I'm going to do that first up. So my top line stays the same. My bottom line, if I think back to what my rule is up here, my rule told me that sine squared theta equals cos squared theta minus 1. So if I rearrange that, then what I can have is some variations. I can have that sine squared theta equals 1 minus cos squared theta by subtracting cos squared theta from both sides. Or I could arrange it to say cos squared theta is 1 minus sine squared theta by subtracting sine squared theta from both sides. Okay, so they're the variations of that first rule that we can use. So I'm going to use that down here. Oops. So my bottom line says sine squared theta. So if I remember what my rule was, sine squared theta plus cos squared theta equals 1. I only want the sine squared theta, so if I take cos squared theta from each side, I'm going to end up with sine squared theta equaling 1 minus cos squared theta. And that's what I'm going to replace my sine squared theta with, 1 minus cos squared theta. Okay, now this is where we need to start thinking back to our algebra topic again. And what I can see on the bottom line is that's a difference of 2 squares. Okay, 1 squared is 1. Cos theta squared is cos squared theta. So I'm going to put little brackets around that top line, and I'm going to rewrite my bottom line broken up into the difference of 2 squares. So I'll end up with 1 minus cos theta, 1 plus cos theta. And now, because we've removed our multiplication between our terms on the bottom line, we can now cancel across the top and the bottom. And what I'm going to end up with is a 1 on the top line and a 1 minus cos theta on the bottom. If you notice, that already is our right hand side. So we've gotten there.